Bismillahirrahmanirrahim. Using Newton's second law, an elevator is moving downward with an accelerated motion. In this problem, elevator has a combined mass of 800 kg and it is moving downward with an initial velocity of 10 meter per second. It slows down and stops. It means that its final velocity becomes zero with constant acceleration and it covers a distance of 25 meters. We have to find the tension T in the supporting cable. We will solve this problem using problem solving strategy as we have discussed earlier. First step is to identify the relevant concept. Since elevator is moving downward with an accelerated motion, so we will use Newton's second law of motion. And the target variable that we have is the tension T in the cable. Second step is setup. First we will draw a simple sketch. Simple sketch is drawn in the previous slide. Then we have to draw the free body diagram of the elevator. We place a big dot that is representing the elevator. Two forces are acting on the elevator. First is its weight, that is in downward direction. Other force is the tension in the cable, T in upward direction. Set of coordinate axes are attached. Since the motion of the elevator is downward, the direction of velocity is also in downward. The velocity is decreasing, meaning it has deceleration, and direction of acceleration is in upward direction. Next step is to execute. We have some data from the statement like initial velocity, final velocity, displacement, mass, and acceleration due to gravity. As the body is moving downward, the direction of velocity is in downward direction, that is along negative y-axis. So we place a negative sign to this velocity value. The displacement is also in negative y direction. So we put a negative sign with this displacement. S is equal to minus 25 meter and Vi is equal to minus 10 meter per second. Mass is given, that is 800 kilogram. Value of small g, that is 9.8 meter per second square. We will apply the equation of motion here to find the value of acceleration along y-axis. So this is third equation of motion, and that is known as 2as is equal to vf square minus vi square. By putting the values of vi, vf and s, we will get the value of acceleration along y-axis as 2 meter per second square. Next we will apply the Newton's second law in component form. Sigma Fi is equal to MAy. The net force acting on the elevator is tension T in upward direction, weight W in downward direction. Net force is T minus mg is equal to MAy. From here we can calculate T is equal to mg plus MAy. By putting the value of mass, acceleration due to gravity and value of Ay, we will get the value of tension as 9440 Newton. Next step is to evaluate the answer. Since the weight of the elevator was calculated as 7840 Newton, tension in the cable was calculated as 9440 Newton. We can see that tension in the cable is greater than the weight of the elevator that was expected in this case. So our result is 2. Thank you very much for watching this video.